Lecture series on theory of computation, and this is Dr. K.N.Sivabalan, professor in IT department, Sri Krishna College of Engineering and Technology. So this is an initiative to launch a sequence of web series on the technical content on each and every subject. And first we are going to take an initiative of launching a series on each technical subject now. So we are going to discuss about the concept called as Turing machine. Is an important topic in theory of computation. The Turing machine, we will be discussing about the fundamentals of Turing machine, what is meant by instantaneous descriptions, and we will be identifying, we will have an illustration, the working model of Turing machine also in this video lecture series. And what is meant by a Turing machine here? A Turing machine is called as an abstract model. It's also called as an abstract machine, which actually accepts recursive and recursive enumerable languages. You can see that a Turing machine have a tape drive. A tape drive as having a sequence of cells in that. A cell is capable of storing one symbol at a time. You cannot store more than one symbol, but here input tape drive is actually called as an infinite tape drive because you can have n number of symbols inside that. And you can see there is a read head here. This is called as a read head. So this read head is capable of reading one symbol at a time, and the state is called as input state. So when you read a symbol using a read head, the state used to change from, maybe it may be remaining in one state, or it can go to another state. So this state is called as input state here. And whenever you have a string is flanked by two input symbols. It's not called as input symbols, it's called as blank symbols, which is used to limit the input string over here. So since I said that input tape drive, this is a tape drive is having an infinite length. So infinite length, when you have a blank symbol before a string, so it actually the blank symbol is used to act as a delimiter for this input strings. So here I have an input string called as A, B, A, and this is flanked by a blank symbol called as B on the left side, and it's also having the right side. So this is called as, when you go for the blank symbol on the right side, it means that is called as the end of the string. And when you go on the left side, if you see a blank symbol, that is called as a starting symbol of the string. Now, recursive enumerable languages, actually this belongs to type 1 grammar. That means the grammar which is used to generate this recursive enumerable languages is called as type 1 grammar. In other sense, it is called as unrestricted grammar or phase structured grammar. So your Turing machine is actually a most powerful machine of all the mathematical models. That means we have discussed about so many mathematical models called as finite automata, that is DFA and NFA. We have come across push-down automata, and there is another mathematical called as linear bounded automata, LBA, that comes under type 1 category. So when you take up Turing machines, this is the most powerful mathematical model which is compared to other mathematical models. So whatever the mathematical models we have discussed, that is finite automata, push-down automata, and linear bounded automata, are actually having less power or less powerful compared to Turing machines. Now, the two blank symbols is acting as a delimiter here. Whenever an input state reads one symbol, it replaces the symbol by a tape symbol, and it moves in left or right direction. Though this read head is capable of moving in both left and right directions. So whenever I read the input symbol called as A, suppose I replace this A by X, then that symbol is called as a tape symbol. And when I replace B, when I read B, and if I replace it by Y, then that is called as a tape symbol. So whenever I read an input symbol, it's always replaced by a tape symbol over here. And this read head either moves in the left or right direction. So this is the nature, and this is called as a working model of Turing machines. It's called as working model of Turing machines. And this is actually exactly simulates the digital computer. This Turing machine exactly simulates the digital computer. So that's why this is called as most powerful compared to all mathematical models. Now we will discuss about what is meant by the formal definition of Turing machines. So since Turing machine is called as a mathematical model, we have to define a Turing machine mathematically. So Turing machine is actually a 7-tuple mathematical model. So what are the 7 tuple? So 7 tuples are Q, sigma, T is called as tape, delta, del symbol, B, and Q0 and F. So what is meant by Q? So this is actually similar to other mathematical models. So Q is called as set of states. So all the mathematical model have a states. That means you keep on changing from one state to other state whenever you read an input over there. So Turing machine is also not an exception for that. So we keep on changing from state to state. So Q is called as set of states. So I have written it as mathematically. So Q varies from Q0 to Qn here. That means you can have n number of states here. And what is meant by sigma? Sigma is called as set of input symbols. And whatever the input symbols you apply in the tape drive, then it is called as a input symbol over here. So in the previous case we have read about input symbol A is applied. So that is called as an input symbol. A or B, 0 or 1, whatever it is called as a set of input symbols. And what is meant by T? T is called a set of tape symbols. So as I said that whenever you read an input symbol from a tape drive, it has to be replaced by another symbol. Whenever you are replacing by another symbol, that replacing symbol is called as a tape symbol. Say for example, if I replace A by X, then X is called as tape symbol here. And if I replace B by Y, Y is also called as a tape symbol. And delta is called as a transition function. So whenever you apply a state, you have an input state, set of states called as Q, and if you apply a tape symbol, one thing you have to understand, all the input symbols is also called as tape symbols here. That means sigma is actually a subset of tape symbols. You can replace A by A. That means the same symbol can be replaced by A symbol. That means A is also called as a tape symbol. B can be replaced by B itself. Then B is also called as a tape symbol. So when a set of states Q, if you apply a tape symbol, then Q will be replaced by another tape symbol, and you can move the head in both left or right direction. L, R. L denotes left and R denotes right direction. So B is called as a blank symbol. That means blank symbol is used to flank the input string on the left and right side, which acts as a delimiter for the string. So Q0 is called as an initial state. So Q0, there can be only one initial state in a Turing machine. So Q0 is also actually is called as a subset of Q. That is, Q is called as a capital Q here. Set of states. F is called a set of final states. So F is actually a subset of Q here. Now we'll be discussing about the most important topic, that is called as instantaneous description. So instantaneous descriptions illustrate the state of a Turing machine. So what is meant by a state of the Turing machine or instantaneous descriptions? So you have a set of tuples here. You can represent the transition of instantaneous descriptions here. So I have written like this: delta of Qi comma A is equal to Qj comma B comma R. So we can see this. So what is meant by Qi? Qi is called as an input state. So when input symbol A is applied on Qi, that is, when input symbol A is applied on input state called as Qi, then what is the output state? Output state is called as Qj. That means it moves to Qj. So there is a transition from Qi to Qj. And then this A is replaced by B. That means obviously the tape symbol is called as B, whereas A is called as input symbol, where you are replacing A by B, so B is called as a tape symbol here. And when I write R, that means the read head moves in the right direction. So I have given the description over here. So QA is called as an input state, A is input symbol, Qj output state, and B replaces symbol A, that means input symbol, and B is called as a tape symbol. So whenever you replace a symbol by another symbol, that replacing symbol is called as a tape symbol. So R moves in the right direction. So this is called as instantaneous description. But when you practically apply it, how come it actually moves? How it actually moves? We'll have a description of it. Now, see here. This is called as instantaneous description. So I am actually simulating the movement of a Turing machine here. So let us see here. Q1 is called as the input state, and I apply the input symbol called as X2. That means it moves to the state called as Q2. Q2 is called as output state. X2 is replaced by Y, and I move in the right direction. Now suppose before applying this instantaneous description, let us assume the Turing machine is of the state called as X1. Q1, whereas Q1 is called as the input state. On the right side you are applying the input symbol called as X2. So whenever as input symbol is on the right side of a state, that means Q1 is called as an input state and X2 is called as an input symbol. So this is the transition now which is applied before this transition takes effect. That means before this instantaneous description takes effect, this is the state of the Turing machine now. So after applying this transition, instantaneous description, what happens? That means this X2 has to be replaced by this X2 has to be replaced by Y, and then it should move on the right direction. So this is the initial state now. Now when I replace this X2 by Y and if I move on the right side, obviously this Q1 will become as Q2. So that's why I make it as Q2, and this X2 will be coming this side on the left. So when X2 comes on the left side, obviously it is replaced by Y. So it will take as X1, Y, Q2, X3, X1. This is the state. That means Q1 will move from one step on the right side and it becomes Q2. Now this we are going to represent with another instantaneous description. I am writing like this: Q1 comma X4 is equal to Q2 comma Y comma L. That means X4 is an input symbol and Q1 is called as an input state, and that is going to be replaced by Y. I move in the left direction. So this is the instantaneous state of the Turing machine before I applying this instantaneous description. That means X1, X2, X3, Q1, X4. That means X4 is going to be applied on Q1 here, and it goes up to X1, Xn. Now after applying this instantaneous description, now this X4 is going to be replaced by Y. So this X4 is going to be replaced by Y. Yes, it is replaced by Y. And then you are moving this Q1 on the left direction. When you move on the left direction, it obviously becomes Q2. So when you move in the left direction, it becomes Q2. So X3 will automatically move on the right side. So this is the state. So we are going to move only the state here, not the input symbols. Whenever I move the state on the left or right, that input symbols will actually replace by itself. It goes over here. So this is the sequence which I have followed here. So thanks for watching the video. Have a good day. This is Dr.K.N.Sivabalan, working for Sri Krishna College of Engineering and Technology, professor in IT department. Thank you.